Good afternoon, I'm Mr. H. Thank you for joining me. Balancing a redox reaction in basic solution. Not too long ago we looked at a similar reaction, the same reaction, but we balanced it with regards to an acid solution. Here we will do the same but with basic solution. You want to start by identifying the oxidation and the reduction reactions, and that's not too hard. You want to look at oxidation states. Iron is going from +2 to +3, so it's losing electron because the positive charge is increasing, and that's your oxidation reaction. And we will write that half reaction here. That would mean that this right here would be a reduction reaction. Think about it. Iodine here is a +5, and this -6 gives you a net negative. Here it's 0, so it's going from a +5 to 0, so it's reducing positive charge but it's gaining electrons. Your reduction reaction is iodate going to iodine, which would be a solid iodine over here. Now the first thing you want to do here is focus on the atoms and ignore everything else. I have one iron, we're good. I have two iodines, one iodine, I'll do that. We'll balance the oxygens. You want to balance here with regards to bringing in water molecules. I have 6 oxygens, I'll do 6 waters. I've thrown it off now in terms of balance. I'm going to remove this designation here, we don't need it anymore. I have 12 hydrogens, and I'm going to balance them out by bringing 12 hydrogen ions. But because I've brought that and we're looking at a basic solution, I must add 12 hydroxide anions. If I've added 12 hydroxide anions here, I must add 12 over here to keep everything with regards to a basic solution balanced as you see it. What else remains here to be balanced? Well, let's count. We have one iron, 2 iodines, 2 iodines. I have 6 plus 12, 18 oxygens. I have 6 plus 12, 18 oxygens. I have 12 plus 12, 24 hydrogens. 24 hydrogens. So everything looks good. What I can do here is combine this, and I will combine it, and this here will cancel out into 12 water molecules. Another thing I can do is I can cancel out this 6 with this 12, and I'll do that. I'll have 6 waters over here and I'll lose this. I'm going to clean this up and then we'll start looking at the charges. When I clean up this side, you know we have 6 water molecules here. When I clean up this side, we lose this. Before we proceed on to checking with the charges, we should check the atoms again. One iron, 2 iodines, 2 iodines, 6 oxygens, that's 12. 12 oxygens, 12 hydrogens, and 12 hydrogens, and we're good. Now let's count the charges. Here in the top reaction, I have +2, +3, so I'll add 1 electron to make it a +2. Here I have a -2, here I have a -12, so I'm missing here a -10. And I can do that by adding 10 electrons. The charges are balanced, but I need to now compare the individual half reactions and multiply this by 10. When I do it, look what happens. I'm going to rewrite everything. I have 10 Fe2 plus going to 10 Fe3 plus and then 10 electrons. Here I have 10 electrons and 6 H2O, 2 iodates. I have 1 iodine and I have 12 hydroxyls. This cancels out with this, and now I can write the net reaction and then everything should be good. I'll have 10 iron 2 plus, I have 6 water molecules, 2 iodate anions, 1 iodine, 10 Fe3 plus, and then 12 hydroxyl anions. Everything should be good, but we have to check it. We'll count the atoms. 10 irons, 10 irons, 2 iodines, 2 iodines, 6 plus 6, 12 oxygens, 12 oxygens, 12 hydrogens, and 12 hydrogens. Now we'll count the charges. Here I have a +20 -2, which is equal to and +18. Here I have a +30 and then a -12, which is equal to +18. So we're good. This reaction here should be good, and everything has been balanced. When you're looking at a redox reaction and it's balanced in the basic solution, you should not see any hydrogen ions. It's okay to see water, and you should be seeing hydroxyl anions, and then you know you'd be good. So our balanced reaction is before you, and you've seen the procedure, and that's all I wanted to show you in this video. Thank you for watching.